All
Yeah, hi,
right,
Steve.
lovely.
Hi, Annabelle. How are you?
Hi, doing good. Hi, Jill.
Hi.
Hey, good to meet you. Good afternoon, ma'am.
Good afternoon. I am unable to see the attendee's name somehow, Anirban. Only the panelist name I can see. Attendees I'm not able to see, but it shows 9 participants. 10.
In total, there are
I
5.
can see them.
I can see them too.
I think
6
something
now.
happened. My internet went off, and then I was able to see them before. Okay, Anirban, can I make you host? And when I say launch the poll, will you be able to? Have you launched poll before?
No, ma'am.
All right. Okay. Let's see. I'm worried about the internet connection going off. I took the Wi-Fi, but the electricity went off. So now I'm taking the hotspot from my phone. If I am the host and if the connection goes away, the session will be disconnected. But I need to launch. Okay, let's see. All right. Okay, thank you so much for joining in. May we know your which city are you from? Which organization are you representing today? And kindly change your chat settings to everyone. Please do change your chat settings to everyone. I am not able to see the participant attendees name somehow, so it will be great. I'd like to personally welcome you. So thank you so much for joining in today. While we are waiting for others to join in, it will be great if you can type in the chat box, which city are you from? And which organization are you representing? Is anyone else able to see the participant's name? Anirban, Jack, sorry, Jill, Steve, are you able to see the participants, attendees?
Ma'am, I can.
I don't know what happened. I am not able to see you.
I can see them.
All right.
If I click on the participants box and then go into you get panelists and attendees.
Okay.
One of which has got a hand up.
Okay, are the participants in the chat? Can we have some? Am I visible? Am I audible? I'm asking to the participants. If you can just give me a quick heads up. Are you able to hear me? Are you able to write in are you able to write in the chat box?
The message says chat disabled.
Chat disabled. So there were some challenges with my usual. Okay, everyone. Panelists can chat with everyone and they can chat. Okay, I've changed the chat settings, right? I've changed the chat settings. Can we try now? Can we try now? Lovely. Thank you so much. Thank you, Mohandas. Lovely. Awesome. Thank you so much. I am still not able to see the attendees' names for some reason. But thank you so much for joining in, Akash, Mohandas, and others who have joined in. And it will be great if you can write your name and which organization you are representing and which city are you from. That would be great while we are waiting for others to join in. Shubhangi is from Pune. Thank you so much for joining today. Mohandas is from Spur Electronics, Bangalore. Great to have you. We are also from Bangalore, Mohandas. So welcome in this session. Can I have some more responses pouring in so I know that I'm audible, I'm visible, everything is okay. We have the right audience in the room. Anand is from Mumbai. Right. Okay. Khushbu is also from Mumbai. Thank you for joining in. Akash Tatavarti. Which city are you from? Which organization are you representing? and everyone else who is joining in Bangalore. Lovely. So thank you so much for joining in today. And I understand that there are so many things happening all around, so many priorities, and amidst all other things that are taking away your time, other priorities in your life, you have still decided to show up for this session today. And this means a lot to us. And what I can assure you is that we will not waste your time. We will give you the most of your time today, and you will walk away with some key insights and wisdom from the experience of our speaker and apply it in your organization. Simplify your life, simplify your work, and deliver safe, secure, and reliable products, right? So thank you everyone for taking out time and joining us today. So when I say that code is going to continue to play a major role in defining our future, how many of you agree to this? If you agree, type in the chat box agree, and if you disagree, type in the chat box disagree. So Mohandas agrees. Thank you so much. Who else agrees that code is going to play a major role in defining our future? Shubhangi agrees. Lovely. Who let's see some more agreements. Srinivas agrees. Suraj agrees. Sridhar agrees. Shiva agrees. Vikas agrees. Did I miss anyone? Anand agrees. Srinivas from it. Right. Suryadev agrees. Lovely. Right. So Suryadev Mayank also agrees. Lovely. So now if I say that the hardest problems in the software development aren't in the code. So the hardest problems in software development are not in the code. How many of you agree to that statement? I'll repeat that. The hardest problems in software development are not in the code. How many of you agree to this statement? Agree or disagree to this statement? Shiva agrees, Srinivas agrees, Rishikesh agrees, Suraj agrees. Lovely. Thank you so much for your participation, right? So as they say that laughter is the best medicine, even for security. Okay. So once Mark Twain said that against the assault of laughter, nothing can stand. Imagine code laughing in the face of vulnerabilities. That's the power of SAST, static application security testing humor, right? So in the grand schema of things, right, securing embedded system is a serious business. But hey, a little laughter can go a long way in building a resilient digital frontier. Agree? If you agree, give a thumbs up. You can use emojis, give a thumbs up if you agree to just what I said, right? Mohandas agrees, lovely. Rutuja agrees, Srinivas agrees. Confusing statement, I will repeat that, right? I mean, how a little laughter can help you build a little resilient frontier, right? I mean, of course, securing embedded system is a serious business, right? But then how about your code laughing in the face of some vulnerabilities, right? I mean, yeah, it's part of the game, but how do we handle it? Handle it with a little laughter, right? So I have some announcements to make. So Jill, our speaker for today, I will be introducing her, will be taking questions throughout the session once she is logically over with a particular section. So I encourage you to keep asking questions. So as and when you have questions, you can post it in the Q&A box. If you wish to speak, raise your hand and we will give you the necessary permissions to speak. Or do write your questions in the Q&A box so we don't miss out in the chat, right? If you write in the chat, the chances of we missing out your questions are high. And she will be taking questions when she logically closes each section, and she'll be asking you if you have any questions. Please ask her. Please take advantage of her presence today with 40+ years of experience. I'll be introducing her a little later. And if you have a hard stop and the session continues because of your questions, then do not worry. The recording link will be shared with you tomorrow. So do participate in the session, because when you participate, you learn. How many of you agree that when you participate, you learn more? Type in the chat box yes or why if you agree. Abhishek agrees. Thank you so much. Abhishek. Mohandas agrees. Suraj agrees. Shiva agrees. Tapan agrees. Srinivas agrees. Pavan agrees. Harish agrees. Shiva. Udakala agrees. Shruti agrees. Venkatesh agrees. Prahlad agrees. Awesome. I love this. Rishikesh Madan agrees. I love this active and energetic audience today. So before we get started, I would like to take you on a poll, right? Let's understand what are your challenges, right, when it comes to creating safe, secure, and reliable software in embedded domain. Are this security? You can choose top 3 challenges. Are security vulnerabilities your number 1 challenge, or resource constraints your number 1 challenge, or amongst your top 3 challenge? Is legacy system integration your challenge, or regulatory compliance is your challenge, or lack of security awareness your challenge? I've launched the poll. Are you able to answer the poll? All right, but I have some challenge. I am not able to see the poll results. So something went wrong because there was a internet connection break. But keep pouring your answers. Maybe Jill, can you see the poll results? Steve, Jill, anyone else, can you see the poll results? Okay, keep your answers pouring in. I'll give 30 more seconds, and then I'll end the poll and launch the poll. So maybe you can see the results when I end the poll.
I think we'll see them when you end the poll. Yes, we don't see them currently. It's still asking us the questions.
Sorry, Steve, I couldn't hear you.
I think we see the answers once you end the poll.
All right. You can answer the poll?
No, I can't answer the poll. I'm a panelist, apparently. But once everyone's answered, hopefully we can see the results.
Okay, I think this is a new setup because our previous Zoom account, we were facing some challenges and we had to change this last minute and take a new Zoom subscription. And this is the first time we are doing the webinar on this. So please bear with the inconvenience, but I'm going to end the poll but you're not able to answer the results. So maybe you can share in the chat box your number 1 challenge instead of top 3 challenge. Guys, you can share what is your number 1 challenge in the chat box. Okay. All right. Abhishek says lack of security awareness. Raja says all of them. Right. So I'll repeat. Is it security vulnerabilities, resource constraints, lack of security awareness, regulatory compliances? What is your number 1 challenge when it comes to creating safe, reliable, and secure software? All of them. Raja says all of them. Shiva says regulatory compliances. Ankur says lack of security and resource constraint. Thank you so much for answering. Right. Thank you so much. Thank you so much. Appreciate all your responses, and sorry for the inconvenience that is caused this time. I'm away from Bangalore. I'm on a naturopathy retreat. So a lot of things, challenges at my end to facilitate this webinar. And I'm sure you can understand the challenges that we are facing here. But nonetheless, this session is really going to be very insightful. I'll be handing over it to Jill. So SAST is like the detective revealing the identity of all the code bandits. So no more mystery bugs, right? So let's meet Jill, the trailblazer of embedded software security. She's going to be the speaker of today with over 40 years of dynamic experience across telecommunications, automotive, defense, and education sectors. She is the director of compliance at Perforce and a driving force at MISRA. Armed with a BSc in Computer Science and Statistics from Newcastle University and an MSc in Computer Science from Brunel University London, Jill's insights reshape the landscape of embedded systems security. Make the most of her wisdom today. Participate, ask her a lot of questions, clarify your doubts, and make the most of her presence and your time today as she unveils the secret to fortifying tomorrow's embedded systems. Right? Over to you, Jill.
Okay, thank you very much for the introduction. I'm just sharing my screen. so hopefully you will be able to see it very quickly. As we said, our topic for today is securing tomorrow's embedded systems, and we're going to look at how we can do this using static analysis. This is me. I think you've seen my picture on the invitation. I can't show you my video because it's disabled at the moment. I'm the Director of Compliance at Perforce. Perforce is a multinational company. I'm based in London. And as we said, I've been working in the software industry for many, many years. I am also joined with my colleague, Steve Howard, who will help me out at various points in the presentation.
Right. Absolutely, I'm manning the questions and answers, so please fire them away, and I'll do what I can to answer in the process, and then we'll talk through some of the interesting ones with each section. So over to you, Jill.
Thanks, Steve. So our agenda today is we're going to look at the embedded software environment and the fact that cyber threats are growing. No matter what we do, they're growing. I'm going to look at how to mitigate the risks of these threats. We're going to investigate how coding standards help detect software security issues, and how static analysis tools or secure tools can help to solve these issues. So let's start with the background and the fact that cyber security threats are growing. Now, some of these extracts are a bit older, but it hasn't gone away. We often hear in the news that there has been some sort of security issue that's brought down airline ticketing services. Big ones, governments are all panicking. They have whole departments looking at the threats that are in software. We've got the aerospace industry. We've got the space industry. Obviously, there's been wonderful innovation in India for space, but there is always that threat, always these people who are trying to get in and destroy our systems. Even in our own vehicles, we have a lot of software, and this gives the opportunity for the bad actors to get in there and could affect our braking system. It could be something minor, could be breaking into the car and stealing it. So in the world now, we have a lot of software security issues, and our software, which is key to everything, can contain bugs. Here we have some more aspects of this in the big wide world. These are aspects that have been found as we go along. We've got connected cars. We all love our new innovation in our cars, being able to go in and switch everything on, connect our phones. Again, this is always a risk. So how do we get to such a state that code defects can enter the software stream? What is the core of this? Why is it there? Well, one of the things is that many embedded systems use C and C++, and they are well known for having undefined and unspecified behavior. So although you may expect it to act in one way, it acts in another way. Or a compiler implements a feature in one way, another one does it in another way. We do have a lot of code reuse and remodeling. Obviously, we don't want to rewrite every piece of software for every aspect of every product. But sometimes by remodeling and reusing the code, we may accidentally introduce some sort of defect. And similarly with code optimization, we make the code more efficient, but introduce a possible vulnerability. external libraries can have many, many problems with them, especially if they're open source, because the updates haven't been checked for the whole of the aspect of security. And of course, our code is getting more and more complex, more difficult to work out what's going on. There's a whole aspect with dynamic memory, because of course that changes within the program and is more difficult to check. And the last one, which I think we all are aware, if you have a developer who is inexperienced and has not been properly trained, they can bring in defects as well. So let's have a look how the actual vulnerabilities can be formed. Vulnerabilities are usually the result of flawed assumptions. We presume that all our input is good. We don't check it. Our buffers aren't big enough. We assign a buffer size and our data overwrites it and goes into memory. And we free our memory and then try and use it again. All of these can result in a vulnerability or an area of code that a bad attacker can use. Now, often with our development, we're looking for new features. All our products must have new features. And therefore, there's no drive to change our basic security aspects. We're more interested in getting new features. So we also end up with a lack of developer education, a lack of new tools, and a lack of that basic thing, the security testing. So how can we do something about all these risks? How can we mitigate the risks? Well, first of all, we need to make sure that everybody in our organisation is aware about security. Because a security vulnerability can allow software to be used in a way that the developer never intended, never even thought about. And as devices become more connected, it becomes even more important that embedded software is designed and implemented with both safety. Obviously, any sort of embedded system has to be safe, but also has security at the top of mind. It's important to remember here that security, we talk about it a lot with our IT systems, so how having our double authentication, things like that. But here we're talking much lower. We're talking about our actual embedded devices. So to help with this, we have to comply with functional security standards. Now, these are relatively new, so let's have a look. Now, a functional security standard requires that security is at the forefront of development right from the start. So it's every part of the life cycle, development, but prior to that, design, from development to test to actually rolling out the product, but also checking security once that product is out in the field. And we want to build a culture of ownership throughout the organisation so that everybody thinks about security for everything that they're doing. Now, these functional security standards, and I'll give you a couple of examples in a minute, describe the behaviour that enforces security, the best practices. And these behaviours can be tested. And this allows us to see that developers are actually considering their security in their software development. Now, one of the ways we can actually test it and observe it is by enforcing a secure coding standard. And that's something we'll talk about a lot in a few minutes. So a couple of examples here. We have the IIC, now get this right, 810001. I keep missing a 0 when I'm talking about it. So let's make sure about that. And this is health software. Now, when it talks about health software, there's all sorts of things here. I was quite fascinated how many medical devices this covers. We can talk about things like our heart monitors. We can talk about diabetes injection mechanisms. But we can also talk about our smart watches that monitor how many steps we do each day. I have one on my wrist at this moment. I'm not sure it's ever that accurate. I'm always thinking I walk far more than it tells me. But our health devices are now spreading everywhere in our lives. And this standard is applicable to all of them. And in part 5.1, which is about the product life cycle, as I was saying, security throughout the life cycle, it describes what we should be doing for security. It also requires that we use a secure coding standard. This keeps coming back and gives the examples of MISRA and CERT. And it encourages the adoption of best practices. These are the known best practices in the embedded software world, and this includes the use of static analysis tools. Another functional security standard is one that came out 2 years ago. It's 21434, which is about cybersecurity engineering in vehicle development. And this takes on, again, the whole of the life cycle, looking at where security risks could be introduced in the development of the vehicle. Again, it's looking at a culture of security. Everything we do, is it going to affect the security? And this is becoming a theme. Again, it's asking for the implementation of a secure coding standard, same examples, MISRA, CERT, and highlights static analysis as a verification method. Now, mentioned secure design best practices, and this is the characteristics of that kind of design. We want to bake in security. As I've said a few times here, we need it from the very beginning, from the design, where we actually say, oh, this is going to be our product, but also what are we going to use to do it? Are we going to use C? Are we going to use Java? What are we going to use? And then we've got to look at the weaknesses of our decisions. Could this encourage a software vulnerability? Could it cause one? Have we checked all the software vulnerabilities with our choices? Once we have implemented our product, we need to scan continuously to look for potential security vulnerabilities. We can use static analysis to do that. We can use other tools as well, particularly for scanning external libraries. And we need to train our developers. They need to understand what is important. Now, I've talked about quite a lot here, so have we got any questions at this point?
Nothing in the Q&A yet that I've seen come through.
Okay, I'm just checking the chat, apart from I can't see it at the moment. There we go. Okay, right. Well, please don't hesitate to ask the questions. There will be another opportunity. Oh, sure. The best static analysis strategy to follow IIC 21434. Well, the best strategy for that is to implement a coding standard. The standard itself, I think it's section 10.5, recommends using a coding standard to deal with the undefined behaviors in the programming language you picked. C, C++ is often used in this environment. So implement a coding standard, use a static analysis tool to do it. And we've got a question, what is the best software for static analysis? Well, obviously we're from Perforce. Perforce has Clockwork, which can implement the both MISRA C, and also Cert C and Cert C++. So it goes into your system. We also have another static analysis tool called Helix QSC, a slightly different area, but both of them are excellent for finding security vulnerabilities. I hope that answers everybody's questions on that particular aspect. Okay, please continue to add the questions. There will be other opportunities where we can answer them going forward.
So Jill, there are some questions in the Q&A. It's in the chat. Basically, Abhishek wants to know how important.
I've answered that all but the last one. The last one's just come up. It's about software composition analysis. It's also a very important part of checking. It's separate from static analysis. Static analysis goes through and analyzes your software with regard to a coding standard or other sort of set of rules, whereas software composition analysis looks more into how the software is formed. So it's also very, very important for this keeping security at front of mind, but it is different to static analysis. Both are very important.
Yeah, a nice way of thinking about it, in my opinion, is always that the software composition analysis is knowing what third-party libraries and so on that you're bringing into your final application, and the security vulnerabilities that they may have based on things like the National Vulnerability Database in the US. Whereas the static analysis is generally going to be used for your own code, or static application security testing is for your own code that you're writing, or in the case that you're taking open source code and modifying it, of course, so that you can understand what the impacts of those changes are in your code based on similar rules. Essentially, at the end of the day, they're looking for similar weaknesses. The ones from the libraries are known in databases like National Vulnerability Database, and the ones in your code, of course, are all being created uniquely from the work that you're doing.
Okay, there are a couple of questions now in the question which Steve is answering about a design.
I'll do those.
Yeah.
Yes, I'll do those in the background. So that's all good. You can continue.
And then there's another one about 26262. Steve will provide the answers to those, but let's move on with the presentation. There'll be more time for more questions later. So let's look at how the coding standards, which the functional security standards all recommend, and how coding standards can detect software security issues. Now, historically, all embedded code was written in assembly. I don't know if any of you actually remember writing in assembly. Unfortunately, I do. And it was just difficult, but it was very, very secure because it was never used with the internet. Now, most applications are now written in C or C++, which are much, much easier to understand. And in the early 2000s, almost all safety critical applications were written in C. Since then, C++ has risen in popularity, and there have been many, many article saying, oh, that C is dying and C++ is going to replace it. I don't think that's true. I think they're going to exist together. However, for safety critical systems, C is still typically the language of choice. Now, that's good, apart from there are security concerns with C and C++. Now, the MEND database, which used to be called White Source, you may know it as one or the other, looks at the vulnerabilities found in open source code continuously. You may run a MEND scan in your own organisation. For Force, we run MEND scans on all our products. Now, in the last 10 years, and I did check this earlier on, 47% of the vulnerabilities found in open source code were for C code, 47%, and 6 were in C++. Now, this may seem absolutely horrendous. Why is the 47% in C and we're still using C? We need to remember that actually the use of C is extensive. So the chances are you are going to find more vulnerabilities in C. And the good thing is, of course, if the vulnerabilities are found, they can be fixed. I don't know if you're aware that vulnerabilities can be categorized as high and medium, low. And of the high severity ones, 26% were C, but C++, although had less vulnerabilities overall, had more high severity ones. So we've got to take these figures in context and say, okay, these vulnerabilities are there, but they have been found. And the top vulnerabilities in both C and C++ were, as we said right at the beginning, buffer errors and input validation. Now, buffer overflows. Well, I'm sure we've all encountered them in the past. I was working in a telecommunications company many years ago, and we had a crash occurred sometimes. It took us months to find this, and that was caused by a buffer overflow that occurred at very strange times. Now, they can have critical consequences because, of course, other areas of code get overrun. And C and C++ are particularly susceptible to buffer overflows because of the way that strings are defined and that there is no implicit bounds checking. I'm sure you've had to write code yourselves where you have to check that the data you're putting in is going to fit. But standard library calls don't enforce any bounds checking, and that is really frequently a problem. Now, this kind of vulnerable code allows a bad actor or a hacker to overwrite other values in memory and even change the instructions to the CPU, mess up the stack, do all sorts of horrendous things. The other area that's a problem is the input validation, where you have uncontrolled format strings. And this allows the bad attacker to actually control how the data is formatted and allows them to look at the contents of the stack, change the contents of the stack, look at the memory, write out random values, and it can actually crash processes. That process could be in a medical environment, it could be in a vehicle, it could be in any embedded software. This allows the attacker to execute arbitrary code, and it's got permission. It's actually gone in and is allowed to do this. All extremely worrying. Now, this is a quote about a study on software defect origins and removal methods. And they found that individual programmers, all of us in ourselves, are less than 50% efficient at finding bugs in their own software. And most forms of testing are only 35% efficient. This makes it difficult to determine quality. I think the quote about the individual programmers is quite an interesting one, because we all know that it's very difficult to find bugs in your own code because you know what it meant to do. However, we have something else that can check what we actually do in our code, which are the coding standards. Now, coding standards have been around quite a long time. If we take MISRA, for example, it's the 25th anniversary of MISRA this year, which is why MISRA C 2023 was released in April to commemorate that. The languages have their own standards. However, different compilers may take only part of that standard, or the different compilers may interpret what the standard says in a slightly different way. And this means that if you have a piece of code that you run with one compiler for this product, but you run it for that compiler with another one, you can have all sorts of errors. Also, if you look at the end of the language standards, you'll see there is a list of undefined and unspecified behaviours. So we already know that these exist, but we have to avoid them. The coding standards themselves capture many persons' years, and I mean years, of experience. And this gives developers a set of rules to follow, and it gives them confidence in what they write. And this greatly reduces the probability of introducing errors. Without these standards and the best practices, we may end up with code with errors, bugs, and it's also very difficult to maintain. Now, features of coding standards that particularly concern us with security are looking at defensive implementation techniques. Now, these allow software to function even when there are unforeseen circumstances. We can't all imagine every possible circumstance that software is going to operate in. And you implementing these implementation techniques starts with the use of recognized coding guidelines. The other part that is very, very important in the coding guidelines is to subset the language. Now, this means we exclude that critical, unspecified, undefined behavior that we know are in the language standards, and we can't have that in our secure system. So it's much more focused on what really matters in the language. And strong typing is the third thing. This is understanding your language data types. How big is an integer? At the very basic point. And this is very important, because if we don't understand this, we can allow overflows. And using coding guidelines with strong typing ensures correctness and consistency. Let's look at a couple of examples here. We've mentioned them several times because the functional security standards require them. One is CERT. You may be aware of the CERT website, which went down a couple of weeks ago. We all went, oh my goodness, where's it gone? There is CERT C, CERT C++. There is also CERT Java, and I believe there's a CERT Android coming through. But CERT C aims to be a secure coding standard aimed at the C language to provide actionable guidance on how to code securely in C. Very simple. And it identifies the critical and unspecified language behavior that we don't want by creating a subset, and has specific rules to address its typing, so we get good, secure code by applying this guideline. You probably have heard of MISRA. I'm on the MISRA C working group. I have been for several years, but some people have been there even longer. It aims to provide world-leading best practice guidelines for both safe and secure application. Again, it has a language subset to prevent undefined and uncritical, unspecified behavior. And it has a particular way of dealing with strong types, which is called the essential type model. So that's one also we see frequently in embedded systems. But there are others, and you will possibly encounter them. These are more lists of vulnerabilities that have been seen in the field. OWASP is a broad project, short for Open Web Application Security Project, and it lists the 10 most important, from the OWASP point of view, security vulnerabilities seen. Now, this list is updated about every 4 years. We're currently on the 2021 list. But this list actually maps to our CWE list, Common Weakness Enumeration. Now, there are 942 as of yesterday CWEs listed. Far too many for anybody to consider. But what there is a top 25 list, which are the ones considered the most dangerous. Now, this list is updated every year, but unsurprisingly, the same ones appear many, many times. And there is also another list that says these are the ones that are most likely to happen over the years. So you would never try and say, I can find all CWE vulnerabilities. You would look for the ones that are appropriate to your system and your language. But these vulnerabilities can lead to bad actors taking over a system, stealing data, or preventing applications from working. So these are lists of vulnerabilities you should be aware of and must make sure your system doesn't actually have these vulnerabilities. That's a very quick view of coding standards. Are there any questions at this point for that?
Been a few questions in the Q&A, which have been very interesting. I think we've answered them all, but one of them, which might be worth just talking about, was with regards to ISO 26262. I know that's functional safety and not really quite aligned to the security topic. But the question was, when is it the right time to implement compliance testing for things like MISRA and CERT?
When's the right time?
The coding standard. Yes.
Okay.
So
the right
I'd be interested to get your opinion.
The right time is as soon as you've written the code. Ideally, you would start checking at the minute the code is committed. We'll talk about where static analysis fits into the life cycle in a minute. But yes, you check your code in, it's complete as far as you're concerned. You run some static analysis with the coding standard that you require immediately. that makes sure that it doesn't get further down the life cycle development and you have to pull it all back again. Get it in immediately. It will help. It helps with education. If you put some code in and immediately get something back saying you've got a too long buffer or something like that, you're immediately learning. And that's one of the really good things about coding standards, is that it educates as you're going. Even when you've been programming for years and years, you can make mistakes and you go, oh yes, I remember I did that once before. It allows you to fix things early in the cycle. Now 26262 doesn't say when you've got to do it, obviously. It just says you must cover all these parts of section 6. Section 6 will actually map directly to MISRA for many of the methods. So get it done as early as possible.
Brilliant. Thanks, Jill. I think that pretty well aligns with the answer we gave. So good work.
Oh, I'm glad we agree. Okay, so let's move on to static analysis tools and how they can help with detecting security vulnerabilities and with implementing the coding standards that will hopefully prevent those vulnerabilities getting in the first place. Okay, so compliance to a coding standard requires the code does not contain violations of the rules or doesn't have any of the vulnerabilities that you've selected. Now, that's a very broad statement. In some cases, it's not possible. It could be that by interfacing with some hardware, you're always going to violate a rule. So if you have to do that, we have what are called deviations. Deviations in every coding standard. And it documents why you have to have this violation in, that you've considered all the implications and that it's been approved. We can't have developers just going, okay, I don't like this one, I'm not going to do it. That isn't how it works. It must be approved. One of the easiest ways of checking for coding standard compliance is to use a static analysis tool. Now, how can we demonstrate compliance? We do a code review. And we use the static analysis tool to automate this. Now, this allows us to be able to repeat the review at any time. We can also see if the next time the code is changed, if it's gone away, or if you've indeed brought in more violations. I hope that wouldn't be the case. Now, there are specific requirements in the coding standards, and we have to show how it's been checked. As I just said, it's just a nicer way of putting it. Now, I don't know if anybody of you have actually ever done a manual code review, but we humans do miss things. We don't understand the inherent weakness of the whole system. We may only be looking at a small section of the code. We may not understand how it relates to other parts. And this all gets too complicated. The human mind can only cope with so much. Now, some of the languages, particularly C++, have some very strange effects. We call them side effects. And not everybody knows every side effect that can occur. I do know of a couple of people who seem to know everything, but they are exceptions. They're actually part of the MISRA group. But we can have that. If I do this, I didn't realize that would happen as well. But for overflow, you can't envisage as a person how this piece of data is actually going to go into this area of memory. It's very difficult. deadlock. Of course, taking a resource, somebody else takes the resource. I'm not going to release that resource till I've done this. It's again difficult for the human mind. And finally, of course, data taint, how the data has been manipulated. Now, static analysis does what computers are good at, which is being able to repeat. They can run the coding standard compliance over and over again. They can run it every minute of every day if that's what you need. Can't do a manual code review like that. But this also allows the human reviewer to do what they do best, which is to make judgments. Static analysis doesn't make judgments. It looks at the code without running it and says, is this good? The human mind can say, hang on, that is meant to do that, so that it's different. It means that static analysis can deal with simple cases very, very quickly, which saves time, and it gives very much yes and no answers. There's another feature of manual code reviews is that programmers like to own their code. And somebody once described it as insulting your child if you tell them that their code is wrong. So it takes the human element out.
Jill, there's a question that has come from Shruti, and she's asking for
Yes.
ISIS 21434. What is the significance of doing static analysis in verification phase?
It verifies that the coding standard has been applied. So it verifies that it's been applied. You then have the evidence for that requirement. Does that help?
Shruti, does that
Okay.
answer it to your satisfaction?
It is actually listed as one of the verification techniques for one of the requirements in 21434.
Thanks, Jill.
I'll dig that out in the meantime.
Yeah, sure, Steve. Thanks a lot.
Thank you for being my typist. Right. So static analysis tools take the human out, allows the humans to do what humans do best, allows computers to do what they do best. So if you look at this in a pictorial manner, a manual code review looks at what the code is meant to do. A computer static analysis doesn't know what was in the developer's mind at that point. And it applies more intelligence, whereas static analysis gives you full coverage of the coding standard, it's inexpensive, it's automated, and it can cover all the coding rules. Static analysis would never replace completely manual reviews, but it takes away some of the sort of day-to-day activity. Now, if Steve's going to just help me out here a bit, we talk a lot about developer education with static analysis because it helps you look at the aspects that you should be avoiding in your code. But we also have something particularly in Clockwork for secure coding. So Steve, can you take us through Secure Code Warrior?
Yes, absolutely. So what we have the benefit actually for our static analysis tools of when we detect an issue. So in this case, the example shown is a null pointer dereference, which can be obviously a quality issue as well as a security issue. When we find that kind of issue and obviously provide help and guidance around it. So for example, if it's a MISRA issue, as we've talked about, then we generally pay the licenses for those standards and so on, so we can record the documentation there and then in the help page as well. So you actually get direct access to the standard for the context of the issue you've just detected in the code. And we do the same for security type issues as well. So in this case, you can see that within that help page, we've also got links out to external guidance for this kind of issue. So a null pointer dereference is something that's mentioned both in the cert standard in various different cert rules. So you can see those listed in the external guidance. And also CWE, there's a CWE 476, which says thou shalt have null pointer dereferences because it's a security problem. So these kind of things are already within our documentation. But we do now have a partnership with Secure Code Warrior, which is a developer learning platform for security awareness, essentially, and secure code development. And again, the same context information can then be passed to that platform. So we understand the CWE, we understand the type of issue we're talking about. We can link directly into that free platform that provides security information and examples and training opportunity for that type of defect or that type of detected vulnerability. So that's what that's all about, and I hope that explained it well.
Thank you, Steve. Okay, so let's have a look at the summary of what the benefits are of applying static code analysis. The most effective way to identify vulnerabilities and weaknesses, that's the things like the CWEs, the OWASP, and to enforce coding standards like MISRA, like CERT, the ones that are required by the functional security standards. They accelerate compliance. They make it do it quicker, make it do it more efficiently. They enforce the coding standards. They detect rule violations, can report back to the developer. You've got a violation here. You need to fix this. They detect compliance issues earlier in development. Run the code, like we said with that question, if we run the static analysis as soon as the code is produced, we can get them sorted out so they don't permeate right through into testing. They accelerate code reviews, which are always part of the life cycle, and they make manual efforts much more efficient. They verify the compliance, which can produce documentation that shows the violations, if any, and provide that evidence that you will need to actually comply with the functional security standards. Now, not only can they do just a one-off run, but they can actually look at compliance over time. So how was it last week? How was it this week? How was it? And produce those suitable reports. But they can also do it across product versions. They provide consistency, correctness, and completeness with regard to secure coding. And they also can provide the base context for developer learning. Okay, we're on to questions now. Thank you for your time. I hope it was useful, and hopefully have lots of questions. I noticed there's one about Ada.
Yes.
Doesn't seem to be anything for Ada. This keeps coming up because Ada we thought was going a long, long time ago, and it hasn't. It's still there. I don't know of an Ada static analysis tool. Do you, Steve?
No, I don't actually. I mean, I think there are some that have been around for a long time as well, like the language. But yes, I'm imagining that security, from a security perspective, probably a lot less of that, because obviously Ada being more secure as a language anyway, the way it's defined, but also the fact that those systems are probably isolated from other systems if they're still using Ada. So yeah, probably less connection with this type of thing. But yeah, unfortunately, we can't provide an answer on that one.
Yeah, sorry about that. Do all C rules covered by static analysis tools? I presume you mean are all of them covered? Yes, they are. They're all statically enforceable. They're all written to be statically enforceable. Clockwork covers most of them. There's 106, I think, at the last count. So yes, they are covered by static analysis tools. Not so much the recommendations. C has recommendations, but their recommendations are only sort of there to provide some context to the rules. So cert C rules, yes.
Does that answer, Yogesh? You can give a thumbs up if it is okay. Any other person, if you would like to ask something, you can just raise your hand, and we can put the question on the Q&A. That will be much more easier also for us to capture it.
So if you don't have any questions, let's trigger some, I just want to, okay. Akash has a doubt.
Boundary check every function.
Okay, Anirban, can you read that out to Jill, please?
So Akash is asking, I have a doubt in boundary check. Like for every function, it is difficult to validate all arguments.
Yeah,
It is
it's definitely a difficult problem. Yeah, sorry, Jill.
No, you carry on. It's fine.
I was going to say exactly that. It is a very, very complex problem actually to understand all of the possible boundaries for all of the functions and all of the arguments. But the beauty of static analysis is that it's essentially doing that. So it is looking at every possible path through the system with every possible value for those arguments and working out which ones will then potentially render a defect or a vulnerability. So that is actually what static analysis is doing, and it can be thought of as essentially an exhaustive search of all of those possibilities. It's very good at doing the traditionally what we call the sort of the error guessing and unexpected code paths through the system. In other words, it's almost working as a non-functional test. It's doing the opposites. It's doing the things you don't expect to be happening. Whereas when you're writing your test cases, normally you're very much following the functional behavior of the system, how it's supposed to behave for certain positive requirements. Static analysis is doing very much the opposite. It's looking at every possible opportunity, regardless of the requirements, and seeing what would happen down that path or that set of paths. So yes, generally that is what is intended to be done, and that's what static analysis should be doing for your systems. Anything to add, Jill?
No, I think that's it. I mean, one of the things we can think about with functions is we have a concept of data flow, where it will take in and look at all the possible arguments and what the effects can be with different values.
Right. So I just want to give a shot to one more poll that I have. Let's see, because I corrected the problems related. I'm able to see the audience attendees now. So let's see if we are able to address this poll. It will trigger some thoughts at your end. Just let me know if you're able to answer this poll. Or if you're not able to answer, at least these questions and the answers would let you know where you stand with respect to how confident you are in identifying and addressing potential security risks in embedded systems. Right? Are you able to answer the poll question? Right. In case if you would like to have a detailed demo with your team, or you want personalized attention, then do fill in the form that is shared in the chat box, and we will get you priority attention from our team. And are you able to fill in the chat question, poll question, Sarama? Oh, lovely, lovely, lovely. Thank you so much. Right. Okay. So there are a set of 5 questions, which these are with respect to the challenges you shared in the beginning. So question number 1 is about how confident are you in identifying and addressing potential security risk in embedded system? I think keep your answers pouring in. Yep. Can we have some more participation? I just have about 20% people who have participated. So right. So I'm waiting for some more responses before I could share the poll result. So, yep. Let's move on to the second question. Let's move on to the second question. So I think 55% people have answered. They're somewhat confident. Yeah. Yeah. 1 second. So now the second question is, how challenging is it to balance robust security features with limited resources in embedded systems? I think most of you are answering all the questions. Great going. I think you're already reading the questions and answering them. And I think the number one on this list is very challenging. Resource constraints seem to be very challenging for most of the audience in this room. Question number 3, how do you perceive the security challenges when integrating embedded systems with existing legacy systems? The number 1 in this list is major challenge. Most of you seem this, for most of you, this seems to be a major challenge. And then how confident are you in meeting industry specific regulations for embedded security? The topper in this list are 2. Actually, there's a tie-up between somewhat confident and neutral. All right. And the last one is, how would you rate the level of security awareness within your development and leadership teams? The topper in this list is high. So you would rate the level of security awareness within your development teams as high. That's pretty good. So I'm going to end the poll now. Thank you so much for your time today. And I would like to thank Steve and Jill from Perforce taking out time to share their insights and wisdom, and the audience who took out time to, for these continuous learnings. And I hope you had some insightful key takeaways. And if this session was good for you, do type in the chat box, great, or give us some love by sharing some emojis in the using some emojis. Do let us know. Surat says, great, thank you so much. So thank you so much. I really appreciate all your time. And we look forward to serving you again and again with continuous learning sessions that can empower you to deliver quality software without getting too much stressed about your deliverables, right? So Venkateshwar, yes, we will be sharing the recording link tomorrow. You can expect it on your WhatsApp. You can expect it in your email and also from the Zoom email that you receive. So thank you so much, Harish, Ratuja, Venkateshwar, Shahul, Suraj, and everyone else who's actively participated. Suryadev, Shubhangi, Shiva, Mohandas, Jill, Venkateshwar, everybody. And sorry for the initial inconvenience. I was facing some challenges with Zoom. So challenges are part of our life, and they give us an opportunity to learn and improve. On that note, I wish that you continue to create safe, secure, reliable software and do all the amazing work that you do for your organization with total ownership and accountability. Thanks everyone for your time today, and we look forward to seeing you again. Take Jill, Steve, if you have anything to add. Otherwise, bye for now.
Thank you. Bye-bye.
Thank you. Bye.
All right, then.
Thanks, everyone.
All right. Thanks, everyone. Thanks for your time. Take care. Bye.
Thank you so much.
Thanks. Thanks a lot.